So in this video, we'll be solving this problem. So what is the coefficient of the term x squared y raised to 9z squared in the expansion of this quantity 2x plus y plus 3z raised to 13? So before we start, I first suggest that you try this first on your own before you proceed on the video. Okay, good. So let's begin. So to solve this problem, at first it might seem tricky. You might think that you should expand it at this thing here, but that's not how this works, because fortunately for us, we have what we call the multinomial theorem. So here it is. So let me just piece it out here. So essentially, multinomial theorem is like a generalization of the well-known binomial theorem, if you know it. But instead of just having two terms, so binomial theorem is just for like this. This time, multinomial theorem is for multiple terms. In particular, we specified here the multinomial theorem for 3 terms. The general term for the expansion of this is given by this formula. So this is our key formula, wherein n here represents the total power of the expansion, n1, n2, and n3 represents the powers of the individual terms. So here. And then n1 plus n2 plus n3, oops, there's a typo out here. N1 plus n2 plus n3 equal to n must be satisfied. Okay? So that's the key. So given this, since our goal is to find the coefficient of this term, then hopefully we want that this thing here must be equal to this, so that the remaining would represent the coefficient. Given that in mind, and on a close inspection, this kind of matches this form, then we will have the following to be able to apply the formula. So I write out here. So in our case, here our goal, the total power of the expansion here. So instead of n out here, in our case, it is 13. So we have here n equal to 13. Then our A, B, and C would represent these 3 out here. So let me write that one down. There you go. Moreover, since we want n1, n2, and n3 to be as such, and take note here that if n1, n2, and n3 are the following, then that corresponds to n1 here being 2. So it doesn't matter. So what I mean by that is, it doesn't matter if there's a coefficient out here. What matters here is that this variable must have an exponent of 2. So we take n1 to be equal to 2. Similarly, we do the same for the others. So n2 here will become 9 to match this one. And then n3 here must be 2. Okay, so I hope you got that one. And then from here, just a quick check of the third condition. We must have that n1 plus n2 plus n3 must be equal to n. But wait a second there. But here, it is clear that when we add 2 plus 9 plus 2, this is equal to 13, which matches what we want. Good, so since we have this one, we can now apply essentially the multinomial theorem, since we have what the important stuff for the formula. So let's do that one. So by the, let's write this kind of properly. So by the let's just abbreviate it as multinomial theorem. There, that's right, multinomial theorem. So by the multinomial theorem, our desired term, must have the following form. So first we have here n factorial over n1 factorial, n2 factorial, n3 factorial. So we'll be using these three here. So we'll have here 13 factorial, 2 factorial, 9 factorial, and 2 factorial. Then A, B, and C, that will represent this with their corresponding powers. So let me write that one down. Good. Now from here, all we need to do is just to simplify this one. So we begin by distributing the square out here. So by distributing the square, let's just copy paste this one. We'll obtain. So from here, we will obtain 2 squared, which is just simply 4. From here, we'll obtain 3 squared, which is just simply 9. And then the variables will have x squared, y raised to 9, z squared. So as you can see, this thing actually is close to what we want already. We want the coefficient of the term x squared y raised to 9z squared. But this is basically this part out here. So all we need to do is simplify this one. Okay, so simplifying, first, note that 2 factorial is just 2. So 2 times 2 here will just be equal to 4. So we can cancel this one out. There. Yeah, then let's expand this 2 a little bit. So we will, oopsies. So we will have here, so expanding 13 factorial, we can write this as 13 times 12 times 11 times 10 times 9 times 8 factorial. And then on the bottom, take note that 9 factorial, we can express that as 9 factorial, oopsies, 9 times 8 factorial. Yeah, and then just copy the remaining stuff out here. So why did I express it that way? Well, observe here that 9 here cancels out, and furthermore, the 8 factorial here cancels out. So all that is left to do is to multiply this, and I will leave that to you as an exercise because it's just basic multiplication. But one can check that this simplifies to 154,440. So let me box this one. Let me box this one. And the term x squared y raised to 9 z squared. So this is the answer we are looking for. Yeah. So pretty nice. So that's essentially it. For this kinds of problem, all you need to do is to take note of this key tool, and then it just flows smoothly from that. So the answer for this problem is 154,440. Good. So I hope you enjoyed that one. Hope you enjoyed that one. If you have any suggestions about further problems you want to try, just comment it down below, and I'll be happy to look onto it. So yeah, that's about it. Have a nice day.